I'm happy to introduce you to Vinay with OPG, Ontario Power, up in Ontario, and he is going to introduce the team and walk you through our webinar today. Thank you, Vinay.
All right, thank you so much for that introduction, and thank you everyone for taking the time to join us today. So we are RT-411. Our challenge and our opportunity is how can we decarbonize capital projects, bringing you best practices with regards to planning, design, procurement, and construction. So today we're going to take you into a glimpse into the future on the topic of carbon reduction and decarbonization on a project. We'd like to think in terms of getting ahead of policy, understanding how we can help you lead your industry, and most importantly, follow sustainable business practices in order to get there. So let's fast forward a little bit. On September 8th, 2025, we will be presenting out on the results. This webinar is, we really want to engage with you as the audience to understand what's important and get some feedback, but we also want to share with you, we're 25 members together on this research team, diverse backgrounds, different industries. It's very important that what we bring to you next year when we present out on our research, we get it right. We get it right not only for the research, but for the industry, so that we can move forward towards keeping the balance within our sustainability. In short, we measure cost. We then learn how to improve cost. In the very similar vein, we need to understand how we measure carbon, track carbon, in order to be able to improve it. Take you a little bit back, so we'll switch the slides, and while that's switching, think about the story of Gulliver Travels, right? It took a lot of tiny Lilliputians to make a difference, to bring the giant down. We're here at the foothills of that challenge and an opportunity to work together in order to do that. So without further ado, I'd like to introduce myself, Vinay Kriplani from Ontario Power Generation. I am the Strategic Excellence Manager in the Project Management Office. We have a wealth of knowledge here on the panel. And I'd like to start off with introducing Hassan. Hassan is a senior sustainability leader at Autodesk, and he is leading our toolkit for carbon tracking and management. I spent several hours with Hassan, and he is absolutely committed to the cause, and we're so fortunate to have him part of the team and presenting here with us. I'd like to introduce James Alloway next, who's a global projects estimating manager at Lionel Bessel with 18 years of experience. And boy, oh boy, did he get us started, kick us off with the research team, a huge wealth of practical knowledge and experience that he's bringing to the team. And we're so happy to have him present here today. Doug Dietrich, who is the chair of the RT-411 team, sustainability manager with Burns & McDonnell. And again, a lot of knowledge, a huge amount of challenge, and really guiding us to stay on track. So we are really happy to have him here. And finally, we have Cheryl Boyning, who is here from Fluor, a global sustainability specialist, and just tons of experience, full of enthusiasm. She walks the talk, boots on the ground, and a ton of field experience that is really helping us formulate this together. So we'll go to the next slide. So before we begin, I'd like to take an opportunity to really talk about the opportunity at hand. And, together with the global construction and building sector, we account for 42% of global CO2 emissions. We have about 2.6 gigatons, as you can see in the bottom section of the shaded pie chart. We have about 2.6 gigatons, and as we know, the industry is fast growing. And just to put this in perspective, that's 2.6 gigatons is about 500 million cars that are being operated for about a year. So it's a significant amount that we have an opportunity to really look at how we can start tracking and minimizing. On the other frontier, in terms of commercial, we do have a lot of programs such as LEED and green building that are helping us. Our team is more focused on the industrial sector and what can we do as we're growing, as we have more infrastructure projects. How can we really formulate the frameworks and the toolkits that can help us as collective project managers build on the sustainability as we move forward. So now that we've set the stage, I'd like to really go through the agenda for today, and without further ado, we want to get right into it. So we'll start off with introductory definitions, and then we'll move into the RT-411 goals and the scope of work, the overview of what the research team and the work in progress. So we want to be able to demonstrate the status of things and where we're at. We want to hold also on the decision making within projects so that we have an influence on the operational carbon. But remember, our focus is on the project phase, on the construction phase, and as we build those toolkits, but we don't want to ignore that future of looking ahead. The tools to track these embodied carbon, how are we going to do that? And strategies to reduce the carbon as we look forward, and then finally what we would expect and the next steps. So before I hand it over to Hassan, we'd like to get to know you a little bit better. We have a few polling questions, so I'm going to walk you through some of those questions, and please engage with us and provide your best answers. So just, we are looking for what sector does your company work in? So we'll give you a few seconds just to answer that question. Next, if you could kindly share with us what your role is of your company in capital projects. The next question is around the location. Where is your company located or present? And the purpose of attending this meeting. What do you hope to get out of the webinar? And please select all that apply. Thank you. All right, with that, I'd like to give Hassan a warm welcome, and I'll hand it over to you, Hassan. Thank you.
Thank you, Vinay. The RT-411 research scope will focus on project-level emissions, more specifically embodied carbon, also called product lifecycle emissions. We're not focusing on organizational level emissions, scope 1, 2, and 3. We'll focus on capital projects, including building projects, infrastructure projects, and industrial projects. Since there is confusion between project level emissions and organizational level emissions, We would outline the connection between both at the end of the report of this research. But let's shed some light on the definitions of the project level emissions and the organization level emissions. Next, please. So let's start with the organization level emissions first. According to the Greenhouse Gas Protocol, that classifies companies' emissions into 3 scopes: Scope 1 emissions, Scope 2, and Scope 3. Scope 1 emissions relates to the emissions from sources directly owned or controlled by the reporting company, such as on facilities and vehicles. So for example, if a company is using electric vehicles for its staff, this would lower its Scope 1 emissions. Scope 2 emissions is related to indirect emissions from the generation of purchased energy, purchased electricity, heating, and cooling for own facilities. So again, for example, if a company is getting its energy from renewable energy sources, this would lower its Scope 2 emissions, unlike getting it from fossil fuel-based power. Scope 3 emissions is another class of indirect emissions. So we have Scope 1 is direct emissions, Scope 2 and 3 are indirect. Scope 3 emissions is another class of indirect emissions, not included in Scope 2, that occur in the value chain of the reporting company, including both upstream and downstream emissions. And again, this is not the scope of the RT-411 scope. We're not focused on organization level emissions, but it's very important to highlight the difference between organization level emissions and project level emission and building the connection between both. So on the other hand, we have embodied carbon emissions, also called product lifecycle emissions, which is the focus of RT-411 research. This is related to all emissions associated with the production and use of specific product or assembly or material in our projects, from cradle to grave, including the raw material, the manufacturing, the transportation to site, the construction, the use and end of life, disposal and recovery of this product. So the differences will focus on project level emissions, embodied carbon of the products and materials used in our projects. However, as I said, we need to clarify the differences between both topics. So I'll go back to the Scope 1, 2, and 3 emissions. According to the Carbon Disclosure Project, CDP, across all sectors, construction, oil and gas, transport, and many others, Scope 3 emissions account for an average of 75% of total Scope 1, 2, and 3 emissions. As you may notice here, there are a few exceptions, such as the cement and steel industries, where scope emissions are, the majority of scope emissions are coming from Scope 1, not Scope 3, but this is the exception. Next, please. Since Scope 3 represent the majority of emissions for many sectors, it's crucial that companies are aware of and are able to measure all the relevant sources of Scope 3 emissions across their value chain. But this is complex. That's why I would see many companies are reporting their Scope 1 and Scope 2 and ignoring Scope 3 because it's a complex topic. And as you can see, Scope 3 emissions have 15 categories divided between upstream and downstream activities. For the most significant by size, Scope 3 categories for the construction sector, for example, where the bulk of emission occurs, are coming from Category 1, purchased goods and services upstream, Category 4, transportation distribution upstream, and the use of sold products downstream, Category 11. It's complicated, that's why companies are avoiding it, but we'll touch upon this and try to build a connection between the embodied carbon and the Scope 3 emissions specifically. So now we'll go back to the project level emissions, which is the focus of our research group focus. And in project level emissions, we have 2 types of emissions, embodied carbon and operational carbon. We defined embodied carbon already as the upfront carbon related to the manufacturing, transportation, and the installation of our construction materials, assemblies, and products used in our capital projects. On the other hand, we have operational carbon, which is the emissions related to the building energy consumption during the use stage of the project. This could be for buildings, infrastructure, or industrial projects, but this is beyond the scope of our research. And someone might ask, why embodied carbon? Why the RT-411 selected embodied carbon as its scope versus operational carbon? And the argument could be that operational carbon, as we speak, accounts for 27% of the total emissions from the built environment, while embodied carbon emissions accounts only for 13%. So it might make sense that operational carbon is more important. This might be the case today, but according to the Carbon Leadership Forum, embodied carbon will be responsible for almost half of the total new construction emissions between now and 2050. So in the coming 25 to 30 years, there will be growing significance of embodied carbon over operational carbon. That's why we choose embodied carbon. Because, and the justification for this is that unlike operational carbon emissions, which can be reduced over time, we can reduce operational carbon over time with the building energy efficiencies, renovations, and the use of renewable energy. However, for embodied carbon, we cannot do that. Once the building is built or the product is manufactured, the embodied carbon emissions is released into the atmosphere irreversibly. We cannot do anything about it. That's why it's more important. There is an urgent need to address this topic to meet our climate targets in the industry. Next, please. So we covered what is embodied carbon. We covered why embodied carbon over operational carbon due to the growing significance of embodied carbon in the coming years. Now we should address how to measure embodied carbon on our capital projects. Measuring embodied carbon requires a methodology called life cycle assessment, LCA. The World Green Building Council assigns embodied carbon emissions at various use stages of the life cycle. And we have 4 main life cycle stages, A, B, C, and D. Starting with stage A, that it's divided into product stage and construction stage, where we have all the emissions related to the raw material, transportation, and manufacturing of a product, A1 till A3, and we call this cradle to gate. Adding to it the transportation of this product, material, or assembly to the construction site, A4, and the construction process and the installation process itself. This would complete the stage A, which is called cradle to end of construction, and this marks the scope boundary for our research RT-411. That being said, it does not mean that we'll not cover the rest of the embodied carbon emissions across the life cycle, but the main focus will cover only the stage A. However, the rest of the embodied carbon emissions across the life cycle stages will be addressed under certain sections of the final report. Because use stage, stage B, including the maintenance, repair, replacement, and refurbishment are very important, should be addressed at the outset of the project, and also the end of life, stage C, and beyond the recycling. If we're considering circular construction, there are strategic decisions that should be made at the outset of the project. So despite we're focusing on the embodied carbon for the cradle to end of construction stage, however, we'll address the rest of the embodied carbon stages. But please note that B6 and B7 highlighted in yellow are operational carbon. So everything you see in green are embodied carbon emissions, except B6 and B7, the emissions related to the energy and water operation during the use stage. And it's worth mentioning that the product stage, stages A1 till 3, accounts for 90% of the total embodied carbon emissions across the life cycle. That's why it's a very important stage. Next, please. And as we said at the beginning, this research team will try to outline and map the embodied carbon life cycle emissions, the 4 stages, A, B, C, and D, map it with the organizational scope 3 emissions being the most significant scope emissions across all sectors. So as you can see here, there are some commonalities between both, such as the stage A4 transport to site highlighted in green under the embodied carbon life cycle assessment, could be mapped with the category 4 transportation distribution upstream activity, also with the stage 9 transportation distribution downstream. Also, you can see stage 4 and D, disposal and reuse, recovery, recycle under embodied carbon life cycle assessment. This could be related to the end of life treatment of sold products. So there is connection between both. The topic is complicated and there is confusion in the industry among both. So we'll try in the final report to outline the connection between both. And with this, I'll pass it over to Cheryl.
Thank you, Hassan. The main goal of RT-411 is to develop an understanding of how to decarbonize the delivery of capital projects. The first step towards decarbonizing is to decide to. Then identify what is the embodied carbon and how to track and measure. We're developing steps to identify potential decarbonization strategies for capital projects, as well as key decisions to be made, including design considerations and techniques that can be implemented that encourage decarbonization upfront, material selection and composition, supply chain considerations, construction techniques. We are reviewing and evaluating the available tools and their applicability and usefulness to capital projects. Next slide, please. Our research is applicable to all industry sectors, but with special attention being paid to industrial projects. We do think this report will be applicable to your project. In order to get a full grasp of capital improvement projects' carbon emissions, it is necessary to understand individually the upfront embodied carbon and the operational carbon emissions, but also their interrelationships. Whole life carbon thinking means considering these emissions together to optimize their relative and combined impacts, thereby avoiding the unintended consequences of assessing each in isolation. A true low carbon project is one that optimizes a capital improvement resource, both to build it and to use it over its lifetime. Due to the immense nature of this topic, we have bracketed our research to owners' decisions to develop, engineering, procurement, product stages, A1 through A3, and construction, A4 and A5 through commissioning. All activities and decisions made after commissioning and startup are outside of the scope of our work. And while operational carbon is excluded from this report, it should not be excluded from your capital improvement carbon considerations. Next slide, please. Due to the scope of our research and the size of our team, RT-411 employed the working group approach, which has divided the scope into significant components. Each group has specific responsibilities, and they then conduct investigations, align and integrate findings. Group 1, led by Hassan, is identifying existing toolkits and sources to track and report embodied carbon. James, who you'll hear from in a minute, is leading Group 2, researching the main materials contributing to embodied carbon, metrics of their emissions, and low carbon alternatives. Group 3 is recognizing the impact on decarbonization of processes in FEP and EPC. Group 4 is to identify the sources of emissions during transportation and construction phases and strategies to reduce those emissions. And Group 5 will identify and evaluate the overarching decisions that must be taken by any entity to encourage decarbonization of a whole carbon life cycle of its capital projects. And next, we have another survey for you. Vinay?
Yeah, so if you could share with us your organizational drivers and goals, what are your company's drivers for decarbonization? Okay, does your company have a decarbonization related goal? If yes, does your organization have a target as to when the organization will achieve this goal? Okay, Cheryl, go ahead.
Thank you, Vinay. Our research has identified carbon reduction strategies need to start at the top and very early, even before FEP stages. Identify your motivation for reducing carbon emissions. Develop and publish your goals. Educate and increase awareness of your internal stakeholders, which will be critical to implementing. Use our research to support incorporating the appropriate technology and tools. Develop and support your supply chain to help them help you achieve your goals. I thank you for listening. Now back to Hassan.
Thank you, Cheryl. So in this section, we'll discuss the embodied carbon digital tools available in the market. And there is a myriad of tools available to measure, track, and report embodied carbon in capital projects. This is a non-exhaustive list of some of the available tools identified by the research team so far that could be classified into 4 categories. Because despite that there is a myriad of tools available in the market, they vary widely in their goal, target audience, cost, and category of tool. So the identified tools that we have listed here on the screen, and there are more than that, we have tried to classify them into 4 categories of calculator types. Starting with the carbon calculator, these tools are typically simple tools that help the project team to have an understanding of the order of magnitude of the carbon emissions allowing for quick decision making at the early design stages. They could be Excel-based tools or integrated with BIM if 3D model is available. The second category of tool is product assembly specific calculators. So these tools assess the embodied carbon of specific building assemblies or components, such as concrete, for example. So they do not perform whole building life cycle assessment. They are focused on one assembly or material or product within our project. The third category of tools are product selection procurement tools. These are most helpful during the procurement process, helping the project team to make informed decisions and choices based on selecting the specific products based on environmental product declarations developed by manufacturer and verified by third party, and in accordance with the ISO standards or AN standard. This is a reliable data sources at this critical stage of the project. So unlike the carbon calculator that used at the early design stages to give an order of magnitude based on generic product selection procurement tools are different. They are based on specific products, based on real environmental product declarations developed by manufacturers. Last but not least, the professional whole building life cycle assessment tools. These tools are advanced and sophisticated. They can conduct detailed life cycle assessment of the whole building or industrial project or infrastructure projects, covering the entire life cycle assessment stages A, B, C, and D. So some of these tools cover the entire scope of work, and we're listing here a few of the tools identified by the team. Also, the research team will try to address the topic of developing a custom carbon lifecycle assessment solution. In case none of these available tools meets your requirement, we'll try to help you to develop a custom carbon lifecycle assessment by identifying the available database sources. Some of them are available for free. So we'll be highlighting all of this in our toolkit section of the report. Next, please. It's imperative to highlight that at the beginning of the research, when we discussed as a group, there was one idea of developing an Excel-based tool as an outcome of this research outcome. However, it was determined that this would not serve the project objectives or being applicable to capital projects because of the limitations and potential problems with the Excel-based tools. Capital projects by nature are complex. While the simple Excel-based tools have a lot of problems, first and foremost, the lack of built-in databases. We don't know where the data is coming from, who's updating these data. Not mentioning the problems with the data input errors. There is risk of spreadsheet errors. Also, there's problems and difficulty in collaborating with integrating with BIM technologies, lack of integration. It's not applicable to, in our opinion, so far, it's not applicable to capital projects. Not mentioning the availability of many Excel-based tools that are already available for free, and we're listing some of them on this slide. And full list of all the available free Excel-based tools will be listed as an output of this report. Next slide, please. Here, would like to give you an idea of some of the features of these carbon calculators available in the market. Starting with carbon calculators that are useful for the early design stages, enabling data-informed trade-offs between project goals, such as carbon emissions versus cost, for example, to give you an order of magnitude of the carbon emissions at the outset. So we have tools specifically doing that. We have other tools integrating with the BIM. If you have 3D modeling, you can link the building elements of the BIM model to the databases to get the carbon intensities for every material and product, and then making comparison, can perform design option comparisons, two options side by side. Some tools can provide 4 options next to each other or more than that. Some tools provide interactive embodied carbon heat map, allowing the project team to visualize through color coding to identify the high intensity carbon emissions areas so they can replace and test another alternatives and see the impact visually in real time while making the design. And finally, some tools, they are useful for product comparison during the procurement stage, making comparison between the available environmental product declarations in the database and showing it visually to select the lowest embodied carbon for your project. Next, please. So our final report will include a detailed analysis and evaluation of each tool identified with comprehensive evaluation criteria. So what you're seeing now is an extract from the report for one of the lifecycle assessment tools, one-click LCA. So it will start with the product description of the category of tool, whether that being carbon calculator, whole life building lifecycle assessment tool. Where are the data sources coming from? Is it coming from environmental product declarations or lifecycle assessment database? And we'll be listing the name of the databases for this tool. Scope boundaries, does it cover cradle to product, cradle to end of construction, or cradle to end of life? So this is a major criteria in selecting your tool depending on your project stages. We'll highlight any limitations that we have identified as a group, applicability to capital projects, and many other evaluation criteria. It's very comprehensive. We'll do this for all the tools that we have identified in the research. Next, please. Another important section of the digital carbon tools is the toolkit section. And in this section, we'll try to answer 2 questions, the what question and the how question. What is the most appropriate software to use at each stage of the FEP stages? So some tools are applicable for FEP stage 1, scoping, study, and feasibility. Others are applicable for preliminary engineering. Other tools are applicable for the procurement stage, selecting the product at this critical stage. And also, this toolkit section will try to answer the how question, how to calculate embodied carbon, and perhaps also how to develop custom solution, especially in case of the industrial project where there is limited availability of tools applicable to industrial projects. And of course, we have the whole building lifecycle assessment tools that could be used across the entire FEP stages, as we said earlier. Next, please. And finally, to wrap up this section, we have identified some of the preliminary findings, 3 findings so far. The first is that the majority of existing decarbonization digital tools are mainly for the architecture, engineering, construction industry, mainly focusing on the building sector. The second finding is that there is limited tools available for industrial projects, especially oil and gas projects. And this is due to the non-availability of data. We lack environmental product declarations by manufacturers for some of the major MEP equipments of the processing plants, for example. So our early recommendation is that you work with your value chain, with your manufacturers, and try to develop these environmental product declarations and provide the data. Once we have this, the existing tools for the building sectors could be used for the industrial projects. There is no problem. So for example, the EC3 tool for the product selection stage at the procurement stage could be used for industrial projects, provided that the environmental product declarations or data are available. So I think we need to work as an industry to push the industry forward, developing more EPDs, having more data about the carbon emissions of our equipment, material, and products and assemblies in our industrial projects. The third finding, and I already touched upon this already, that Excel-based tools or piecemeal decarbonization digital solutions are not applicable for capital projects. We think that the way forward the best tools are lifecycle assessment tools, such as the 7 tools identified in the slide. And I'll pass it here to James.
All right, thank you, Hassan. So the research team is using 2 different case studies to demonstrate the principles and information gathered by the team. The first case study is a standard solar power plant that uses adjustable photovoltaic panels on a steel structure. This is a project at the very beginning of its project lifecycle in FEP0. The second case study the research team is using is an industrial petrochemical project located on the US Gulf Coast. It is a C3 splitter which transforms a mixture of propane and refinery-grade propylene to polymer-grade propylene. The information that the team is using is based on a project at the end of FEP2 or FEED, with typical engineering deliverables at an issued for design level of development and a detailed 10% estimate available. We are utilizing these case studies at 2 ends of the project spectrum to demonstrate the different analysis that is available to each project dependent on where they are in the project lifecycle. All right, so our research team is focused also on the 5 material groups. So this would be stages A1 to A3, as we just talked about. We're looking at concrete, steel, glass, asphalt, and pipe. Concrete and steel are well documented as being 2 of the biggest carbon emitters out there, and 2 materials fundamental to a modern society. These materials overall were chosen due to their importance and prevalence in the commercial and infrastructure space, as well as the heavy industrial environment. When it comes to pipe, we are looking at doing some comparisons and analysis between the several different metallurgies: carbon steel, stainless steel, HDPE, PVC, and concrete pipe. We are looking at the hurdles faced by the industry to decarbonize each of these materials and focusing on methods available to reduce embodied carbon in the current manufacturing process, as well as possible alternative materials that are available. So let's give a peek behind the curtain here on what the research team is looking at. And so here are some of the details on steel that will be discussed in our upcoming paper. So let's talk about the steel manufacturing process. The first step is the mining of the iron ore. The ore then goes to a steel mill for reduction and smelting. And the last step, the structural shapes are made at the steel mill, are purchased and sent to a fabrication shop where the steel is modified to align with the detailed design drawings. I've included some average numbers for embodied carbon over the steel production process. These are stages A1 to A3. These numbers above total to 1.7 metric tons of CO2 equivalent per metric ton of steel. And you can see the largest carbon emitter by far in this process is that middle block, which includes the reduction and smelting process at the steel mill. It is important to note that the carbon footprint of steel can vary noticeably depending on the process and fuel used for steel production. The traditional route of a blast furnace and basic oxygen furnace accounts for roughly 72% of the current steel production. It is the largest carbon emitter. Direct reduction of iron and the electric arc furnace account for about 6%. And then scrap steel sent directly to an electric arc furnace accounts for 22%. The electric arc furnace has a noticeably lower embodied carbon number due to the use of electricity to produce heat. Slide. So recycling is not a silver bullet for all problem. It certainly helps. Steel is the most recycled material in the world, and about 40% of all steel produced is created through recycling. However, According to the World Economic Forum, steel demand is projected to rise by 30% by 2050. So we're not able to recycle our way out of this problem. We need to decarbonize the steel production process. So let's talk about what that might look like. The current path to decarbonize steel relies on increasing the steel produced from the DRI to electric arc furnace process. As mentioned, this process is currently at 6% of total steel production, and it represents 1.4 metric tons of CO2 equivalent per metric ton of steel when we're talking about embodied carbon. Renewable electricity would further reduce the carbon footprint. And we are starting to see several steel mill projects come online in the next few years that will run on solar, wind, or even hydro power. Growth trajectory of the DRI and electric arc furnace process would also require that natural gas or coal be replaced by green hydrogen as a reducing agent in the direct reduction process. Challenges associated with scaling up electrolytic hydrogen production to an attractive price point. There's other challenges that are associated with quickly developing the hydrogen-based DRI at a overall commercial scale with the type of growth we need. Several companies in the world have announced preliminary investigations into the use of green hydrogen with their steel production. Now, what about carbon capture? Well, carbon capture, utilization, and storage is probably not an ideal solution for steel. At the moment, there's only one commercial scale carbon capture plant for steel making, and it only captures about 20 to 25% of the plant's emissions. However, 70% of our steel is still made from the blast furnace and basic oxygen furnace process. This is the most carbon intensive process for steel making. So if we cannot move more steel making over to DRI and the electric arc furnace, carbon capture may be required in order to reduce the carbon footprint. Other options on the table here, some new technology options. You've got molten oxide electrolysis. It's a new technology that does not produce CO2 emissions with an initial commercialization date of 2026. So that is coming up. There is also the blue blast furnace and the thermochemical sector coupling. Both of these are promising because it points to retrofitting existing blast furnaces. So both of these help by effectively using a syngas as a reduction agent in those blast furnaces to reduce the carbon footprint. So some future things to look forward to there. Next slide. All right, let's talk about construction execution. So we talked about materials. Those were A1 to A3. Now let's talk about construction execution. If you're looking at that life cycle assessment, you're looking here at A4 and A5 in the LCA process. So the research team is also looking at ways to reduce the carbon footprint and improve sustainability of the construction execution effort. When it comes to logistics, we plan on using the case studies to demonstrate the supply chain analysis to determine carbon emissions as a possible decision point, balanced against cost and schedule when evaluating bidders. We're also looking at methods and options for carbon reduction when it relates to construction equipment, as well as temporary facilities and site services. Overall, the goal here is to develop an actionable set of activities to reduce carbon emissions and improve sustainability during the construction process. With that, I'm going to hand it over for another poll we have here.
Okay, thanks so much, Jim. So we'll get, before we get into the first question, I'd like to encourage everyone to please put your questions in the chat feature, and we will make time to answer your questions at the end. So the first polling question is decarbonization means and methods. Which, if any, of the following have you established? And please select all that apply with respect to decarbonization. All right, so moving on to the next polling question. So if your company calculates embodied carbon at the project level, what is your method or your source? So again, select all that do apply. Okay, if the answer is in-house with an industry available tool, what type of tool do you use? Hassan took us over some of the tools. We're interested in what type you do use as part of our research data. All right, so the next polling question is which, if any, low carbon materials or elements or products are you sourcing? Low carbon materials, elements, or products. All right, next polling question. Which of the following practices are you currently employing on your projects? Again, select all that do apply. All right, next polling question. What are the biggest challenges you face when trying to decarbonize? Planning to, trying to decarbonize. Again, select all that apply. This will give us an idea of where we can focus more on our research. And which aspects of the proposed work are you most interested in seeing? So we've taken you through the scope of work, some definitions, introductions, and some examples. What are you most interested in seeing coming out of this research team in 2025? All right, with that, I'd like to introduce our chair of RT-411, Doug. Floor is yours.
Great, thank you, Vinay. So the question is, how can we accelerate adoption of this work and gain traction? As the graphs shows, the quicker we adapt our ways and adopt decarbonization practices, the sooner we will realize our common goal of reducing harmful emissions. To take action, people need to be aware of the issue and why it matters. To communicate effectively, we need to use language and terms that resonate with executives, project managers, and the range of stakeholders in all participating and affected groups. For them to embrace and apply decarbonization practices, we need to put ourselves in their shoes and tailor suggestions and recommendations that are sensitive to their specific roles and responsibilities. Finally, it's imperative that we communicate in a collaborative manner with suppliers, recognizing and rewarding their efforts to provide essential information about the embodied carbon of the materials, equipment, and services they provide. Next slide, please. Looking forward, what can you expect from our research team? We plan to present our findings at next year's conference in the summer, and of course, hope you'll be able to join us for that in person. Later in 2025, we will publish our findings. The purpose of the report is to provide you, the practitioners in our CII member organizations, with actionable information that you can use to provide value to your project owners, team members, partners, and communities you serve. There will be a guide that outlines the major decisions throughout the project lifecycle that drive impact. Many of these decision points come up in the earliest of the phases, even before FEP1 in some cases, so we especially want to emphasize the importance of early engagement and serious consideration upfront. We will also provide a summary of the numerous software tools available for you to understand planning, design, procurement, and construction impacts on our project's embodied carbon results. The toolkit will provide guidance for which software applications may best be suited to inform wise decisions at each particular phase of the project. Next slide, please. Here we just want to say none of this research team's work would be possible without the strong and enduring support of the University of Texas at Austin, specifically principal investigators Dr. Fernanda Leche and Dr. Chris Rausch, plus doctoral student Emmanuel Poser. On behalf of all of our presenters today, Vinay, Hassan, Cheryl, Jim, and myself, we want to thank you for joining us, and now we look forward to your questions.
Okay, thank you so much, Doug. With that, we have a few minutes left. So at this point, we did have quite a few questions, and we really appreciate the questions because the questions in themselves are sort of direct us and help guide us. But at this point, I would like to give the audience some time back. We really appreciate you being here, engaging with us. and we will answer the questions and send out as part of an email to the entire audience. Please be connected with us. If there's any interest, any ideas, do let us know. And we look forward to seeing you in September 2025, where we can present out and start using the tools to make a difference to sustainability. Thank you, everyone. End of webinar.